All right, so I'm here today to present what we're calling block-powered virtual robots and more in your browser. Uh, Previously, I'm with the NetsBlox group. If you saw Devin's talk earlier or anything Brian or Akos did, you may be familiar with some of the other things we work on. If you've been to SnapCon and Snapshot all the time, you've definitely seen us present some robotic stuff before. We've been doing a lot of summer camps, and now previously we were only doing online classes. COVID and having to work remotely was a big motivator in our project. Being able to use a tool like Snap or NetsBlox in our case, where students can work remotely and they can share code remotely, is so powerful when they can't meet in person. So previously, you may have seen us demonstrate a robotic simulator. If you're at the last SnapCon, that was basically a Unity game that students would install on their computer, and they had robots in it that they could talk to through their code. We're presenting a new version of it that is much more accessible and something that we can actually make available to you people here at SnapCon. So if you didn't see Akos or Brian or Devin talk about NetsBlox already, NetsBlox is a variant of Snap. So I kind of say like Snap adds a lot of functional programming to Scratch effectively. And then we add an extra layer of distributed computing topics on top of that. So we have programs can send messages to each other over the internet. They can talk to web services and other similar internet connected devices and such, all through blocks. And what's been very useful, like I said, is that two students can actually log into the same program and work together. And that has been really nice that we can share things through the cloud. So as a quick example, this is a photo of our lab where I am right now. We got this through a call block, which says, reach out to the server, get me Google Street View and tell me what the image will be for this address. And all the hard part of talking to that API is done for the student through our server, through this block, that they just have fields, they have input slots like any other Snap block, but they can reach out across the internet and get something really useful. And we have this kind of setup for a lot of different services already. But one thing that is really sort of unique about our approach is that we also do this for robotics. So normally, if you're writing code for a robot in something like Snap or Scratch, you're writing code that runs on the robot typically. That's the more common approach we've seen, but we do things a little differently, where we have the robots are implemented as a web service, where the students write code that sends commands to them over the network. So rather than a student uploading firmware, they just send their commands and all their code lives in their Snap window on their browser. Now, this also lets us do some neat things, like we have a cybersecurity course where, like the cryptography stuff you saw earlier, we have some similar things where because this is all over the network, students can see each other's commands and they can spoof commands. So we gave them the ability to encrypt their commands as well. So we have some existing educational curriculum about these robots and various topics. So I mentioned we had a previous Unity-based version that was basically a video game, and we thought that was a really clever approach. So this is our virtual robotics platform here, where we thought, oh, we'll make a video game. Kids love video games. It'll look really good. Yeah, unfortunately, when we need to move things back into schools, we found out IT departments at schools don't like video games all that much. Or if they do, they don't like them being installed on the school computers, and especially multiplayer games. It was such a headache that installing something was just not working. A lot of the computers at schools couldn't handle it. If they could, the networking was such a pain. And we had some other frustrations, like this was a separate full screen window, which meant students had to switch back and forth from their robot code to their view of what their robot's doing. It wasn't too helpful. Also, the servers are very expensive because we needed to pay for a separate server instance for every single student's online environment, which was not going to scale to even, it didn't scale well to dozens of users, let alone hundreds. So now we have, as part of NetsBlox, this extension system where we can bring in a custom JavaScript module, basically, that brings in new features and new blocks that work in special JavaScript-y ways that let us do some new things we couldn't do before. So now we have a simulation that's written using a custom server and a client that exists totally within the NetsBlox browser window. And that has been a lot smoother. We've done, now we've done an online class or 2 online classes and 1 in-person class using this setup. And the students seem to really like it. They seem to appreciate that, you know, the simplicity of it, and it does make setup so much easier for activities. And one thing here, we had students in the classroom, some were using like an iPad, some were using a Chromebook, and our Unity version or old version, that was just going to be, sorry, you can't use a Chromebook, sorry, you can't use an iPad. Now we can say, oh, of course, you can use anything you want. It all runs in the browser. Any modern computer should be able to run it. And even though, you know, we have returned to the classroom, these simulations allow us to do things at a lower cost. They let us set up things so much easier. With robots, repairing them required the teachers to know a lot of technical skills. You know, we had a lot of wires on our robots, and if you put them in the wrong place, they don't work. And it's not quite so easy to diagnose, even with a circuit diagram. We had a Wi-Fi module that would often be removed by a student or need to be replaced and get installed facing the wrong way or offset by a bit. It just was a huge hassle to provide technical support for all of this when a simulated robot works all the time. If it's not working, it means the whole simulator isn't working. We also, with simulation, we can do some things that wouldn't be possible in the classroom otherwise. Like, we have an example. Originally, this example was a radioactive waste leak that the robot needs to track down. And if you leak radioactive waste in the classroom, it gets some calls from some parents. And if you do it virtually, it's a lot safer and easier to explain. We've changed that to be trying to locate buried treasure just in an area. We think that would be a little less scary, potentially. We think that's a more fun, friendly activity. But it's the same thing. We couldn't put a metal detector on our physical robots. They don't, they're too small for that, and we can't bury treasure in the classroom. The floors just aren't made for that. So a lot of the stuff that we couldn't do physically, with virtual robots we can. And a big deal is that students can take their robot home and there's no logistics issues. They have their robot, they just go to the website and it's there. So again, we have been using this in classrooms and students seem to be responding positively. Now for the more exciting part, we're ready to share this with everyone else. So if you go to extensions.netsblox.org, I will go along with this. So there are some links here for, these are often works in progress. We're working to come up with new features to make available through this. But for now, if you click the RoboScape Online option here, that should open a very similar interface to Snap, or NetsBlox here. And we have the ability to go into this puzzle piece menu. I go into this drop down here. I can click new room. And I will just show one example of an environment that we like. I apologize if it's being, hopefully it's not being too buggy today. We have this nice 3D view. So I may need to, there we go. Oh, sorry. I just rebooted the server and sometimes it's been a little iffy when I do that. So let me, all right, it is warmed up. So over here, and if you're following along, you can click in this 3D area and you can drag around to move the camera. And you can use the arrow keys to move it in a 3D space. Down here where it says robot ID, if you select well, in my case, there's only one robot in the room, that allows for switching to a following camera, which unfortunately here, this wall is in the way. There's a first-person view from the robot's perspective, and then the free camera that I was using before. As an example, I'm going to, give me 1 second. Sorry, I need to log into NetsBlox. It lost my login here. Just don't want to broadcast my password from my password manager and to everyone. Okay, so now if I open my robot controller, so now I have a little program I've written here. Now I can drive my robot around. This program, I can make this available to anyone who wants to test it. But here I'm driving my robot through this environment. And this is something kind of similar to what we've done in real life, where we had students drive robots around through an obstacle course and yeah, complete various challenges. So I'm going to, in the interest of time, to make sure we get to show some other cool things. Yeah, for example, a different environment. This is, all right. So this environment here, although you can't see it, this robot has a LiDAR sensor attached to it. So it's actually locating, my hands are not on the keyboard. It's autonomously finding this box and it's going to push it off the table. Might take a second, but it'll get there. And what's neat about this is we can just add these extra features and new sensors that students can work with. And it's been very successful that they've been able to pick up how to work with these. And here, hey, successful robot. All right. So here our LiDAR sensor is just another web service, basically. So here the robot has entry in this LiDAR sensor service where you can query what it sees around it. All right, and there's one last quick example. Let's see. So I'm going to use a very simple code here. We have a little path here for the robot to go down. And this is also using that LiDAR sensor. And we had a very complex bit of code with all these if statements and different conditions. that we were using before. And then a student actually came up with this code where all it does is it takes the LiDAR reading from the left side and tells the wheels on the right side to use that as their speed and vice versa, which causes it to steer away from obstacles and towards the center. As you can see, it made it past that little bend there. All right, so to wrap things up, we think these robots will be very useful. We think it will allow us to teach computational thinking with new robotics, and especially autonomous concepts that we haven't been able to use in the past. So thank you for watching this. If you did play around with this, I really hope you enjoyed it. You're more than welcome to use it yourself if you'd like. If you do want to use it in the classroom, please reach out to us first, though. We can add more server capacity. If you run into any issues, please feel free to reach out to me at gordon.stein@vanderbilt.edu. All right, thank you.
Thank you so much, Gordon. A round of applause.